took notes on how to do it because I wanted to still learn. I still learn how to finish artifact projection.
Awesome.
Yeah.
Very cool.
That really helps too, because sometimes, like, especially with computer stuff, sometimes I just like it takes a couple tries and then oh, hey, love that.
Okay, I want to start this next section, guys. And so, you guys ready to get going? Okay, so what I want to talk about next is what we're going to do next with this data. So, this is just starting to work on the control subjects. We got through all of our healthy young adults through the 30s, 20s, 30s, 40s of the subject numbers. We're now in the 81 here, at least in my processing. And so, we're going to have that finished up pretty quick. Just a couple minutes we'll be done with that. And that's a pretty fast time frame to process through all these subjects that we've been working with. And so once that's done, somebody mentioned it earlier not too long ago, what we want to do is, one, we want to create a grand average then, right? Okay, so when you create your grand average, you're going to have to create your grand average for different groups. You're going to have to create one grand average for your controls. You're going to have to create another grand average for your patients. And you're going to have to create another grand average for basically your young adults. Okay? So you're just going to do that the same way that we've done that for everyone so far. Okay, so you're just going to do that basically times 3 for 3 different sets. Now our controls, right, we're going to have a sample size of 6. Our patients, we're going to have a sample size of 3. And your young adults are going to have a sample size of basically 30. Okay, so that's the first thing that we're going to do when we're done processing this. Okay, the next thing that we want to do is I'll show you guys an example of how to make figures again. Would you guys like to see that?
Yes.
Okay, so we'll revisit that a little bit, and I'll give you an example of, if I were doing this, how I would go about making some figures. Okay, so we'll do the grand averaging, then we'll do some figures. Okay, now one thing I might do is well, I'll probably work with, I'll make a figure for our controls for our sample size of 6. And then what do we want to do after we create figures? Or what do we need to do? Fine, you guys have already done this. What do we do? Well, that's what the figures are. The figures are the plots. We want to measure them, right? ERP measurement tool, we want to actually get the stats. So I'm going to show you basically how to do your stats for between group analyses. Okay, so let's talk a little bit about those analyses while the data is processing in the background. What was the analysis that we said we wanted to do last class, or our last session here for our between group goals? You guys remember? Okay, we said we wanted to find a condition by group interaction with a 2x2 ANOVA. Remember? Mm-hmm. Okay, so for that, we want to do, the key here is we're looking for a condition by group interaction. Okay? So that's kind of our gold standard, and the way that we're going to look for that is basically with a 2x2 ANOVA. Okay? Now how many of you guys remember what a 2x2 ANOVA is? One person out of 20?
Like, I I remember it, but like I took stats 3 years ago.
Okay, that's fair.
Yeah. But I do remember it.
Okay, so in general, right, it's just another stats test. It's just a way of conducting kind of multiple t-tests at once. Right? You guys remember that? Has anybody here not taken statistics? Okay, good. So at least we have that foundation. We'll get to kick some of the dust and rust off if we need to. So we're going to work specifically on how to identify this condition by group interaction. Now, when we look at this 2x2 ANOVA, okay, in order to get our condition by group interaction, one thing that's useful to remember is that when we do that, when we talk about ANOVAs, okay, they're kind of like multiple t-tests. Okay, so let's just think about this, okay? You might have a set of ERPs for patients, and another set of ERPs for controls. And in patients, you might have the ERP that looks like that. All right, and this might be old hits. This might be new correct rejections. You guys have all seen this, right? Let me plug my battery in so the computer goes working. Okay, so you might also see in controls that it looks, you might have a different pattern of ERPs, right? And this could be old hits, this could be new, correct, rejections. Okay? So what we're seeing here is an example of, very simply, you could have differences in the ERPs for our conditions. So again, we're talking about looking for a condition by group interaction. So first we just need, your first factor is condition. Okay? So in our ANOVA, okay, you're going to have two factors. Okay? One factor is condition, and the other factor is group. Now within our factors, we're going to have two levels. Your condition, in this case, would be old trials or hits, and new trials or correct rejections. Right? For basically factor 2, okay, which is group, what are your two levels of the factor of group? Yeah, patients and controls, right? So patients is one factor. Bless you. And controls is another. Okay. Make sense? So what we're going to look at is to see, is there a difference between these conditions that varies as a function of this one? That's what your 2x2 ANOVA is going to give you. Okay? Now there's free ANOVA calculators on the internet. You can use that. I think Vassar Stats has a really good one. If somebody emails me later, maybe I'll even be reminded to put it up on the class website or something like that as a link to it. But if not, you can find it. You can also, I know you guys get free SPSS on campus. And I know you guys are trained in SPSS and you've taken classes and passed it and how to use it to run these ANOVAs. So you have lots of different options for how to calculate these things. Okay? So let's say that you're going to, say, compare this to that. Okay? What would that look like on a bar graph? would kind of look like that, right? This would be up here, and this would be there, right? So this would be your hit, and this would be your correct rejection. And that would be for patients. Yeah? Does that make sense? Okay. Are there any questions about that? Can you see it over there? You able to see what we got? Okay. So how would this, let's say that you want to take that same time frame, let's say this is 400 to 600 milliseconds, and you want to grab, let's say, 400 to 600 milliseconds in our controls. How would that look? Kind of similar, right? Okay. So this would be of your controls. Okay, this would be this would be correct rejections. Now, so far we've only done one group, right? We've just looked at controls. And we would run a t-test between this versus that to see if it's significantly different, right? Every person in class has done this. You guys understand? Okay, so now all you would be doing is basically running a t-test between this group, but then you'd have to run a second t-test between this group. Conditions, right? Because you want to know, are hits bigger than false or correct rejections in the controls? Now you would need to run a third t-test here, right? Which is, you need to run a t-test between the difference between this and this, right? So let's say this difference, okay, if we plot a graph, okay, of this difference for, let's say, patients. Let's say that difference is about there. And let's say your controls, see how this big difference here is bigger? And this here is smaller? That's a subtraction, right? That our t-test assesses for each individual group. What we're going to do, okay, is now, this is our difference, right? This is basically your difference between conditions, right? This is your old minus new, and old minus new, right? So you're subtracting how much space is there between the old and the new amplitudes. Does everybody feel like they're on board with this idea? What?
I'm not exact.
Okay, so, Huh? You are?
No, it's when you moved away, I was able to see it.
Okay, so this is just, see how this is shorter and this is taller? See how this is shorter and this is taller? You don't see that this red line is shorter than that red line?
Oh.
See, so it's red. Okay, see that red line is shorter than this red line? See how this is shorter, this red bar here? Shorter than that red bar?
Okay.
Okay. So this represents the subtraction of old minus new. Just like this represents the subtraction of old minus new. The difference between this amplitude and this amplitude, which represents this, or I'm sorry, it actually represents this versus that. Right? This is just like the graphs that you made in all of your results sections. Okay? All I'm trying to get us to is the idea that you can do a 2x2 ANOVA, okay, in order to identify your condition by group interaction if you want. But mathematically, the way that a 2x2 ANOVA works is it works out to be the same math as doing a t-test between the difference waves of the conditions between conditions. Or excuse me, it's a t-test between groups of their respective difference waves. Okay? So if you want to know if this graph is statistically bigger than this one, right? You want to know if that's statistically significant. That is basically a t-test between groups of the difference between conditions. Okay? Does anybody want me to repeat that? Yeah? Okay. So what a 2x2 ANOVA is doing is trying to identify, is there an interaction or a difference between the conditions and the group? It's the same thing as doing a t-test between the groups of the difference between their mean amplitudes between conditions. Okay? So instead of doing a t-test here and a t-test here, or you would just drop these 4 parameters into a 2x2 ANOVA, it's the same thing. Okay? You subtract those conditions for each group and you get a value. And those groups are going to have different values, and we can run a between group t-test in order to identify if the groups are different in their difference waves for the memory conditions. All right? You gonna want me to say it again? He's got it? Okay, so we've been doing a type 1 t-test for one group. We are now going to do a type 2 t-test because it allows us to do the same thing as an ANOVA, but instead with a little bit more simplicity. Okay? It's the computational equivalent. Okay. So, we finished that. We got all of our subjects done, so now we're going to create some averages. Okay? Let's create those. So all you guys know how to do this already, so you can just watch me do it real quick and see how I get reminded. Okay, we're going to average across groups. Let me remove all these. I'm going to add some new groups. Add some new stuff in there. I'm going to grab my controls, which is basically subjects 81, 82, 83, 84, 85, and 87. Okay. It's going to ask me to save the list, which I'm going to do. I'm going to call it controls N of 6. And you just hit run. And it'll ask us to save that when it's done. And that'll take care of our running our controls. Do you guys want me to keep these notes on the board, or you want me to erase it so you can see what I do with the GUI? I tell you what, I'll move the GUI over here. How about that? Is that better? Mm-hmm. Okay. So I'm just going to name this controls with an N sample size of 6. And I'm going to save that ERP as, and I'm going to click same as ERP name and hit OK. Okay, so now I've got that. It's saving. I'm going to do that again for my patients. Okay, so let's create average across ERP sets again. I can remove all these and add new ERP sets, which in this case I'm going to come down to my patients. Subjects 91, 92, and 93. Hit open. I'm going to save that list here. This time I'm going to call it patients. to say sample size n of 3. Hit save. Just like before, you just hit run. It'll ask me to save that again in just a second. Okay, so I'm just going to say patients n of 3. And hit the option to save our ERP as. Click Save as ERP name. Hit OK. Okay, so in a moment this will be done saving. And we can see that when I click on our ERP sets menu, we can see our set of controls, and we also have the set of patients. So we can select back and forth between them. Let's work with the controls right now. Let's just see what's normal. Okay? So let's plot some ERPs. How about, I like the ERPs for high confidence versus low confidence recognition. So I happen to know that that's conditions 87 and 88. So I'm going to type those in. And we are just going to do that. And let's say that we look at, it's like P3 here. Okay? Well, how about I erase all this stuff now? I didn't realize this was up here for you guys. Okay, so let's bring this over a little bit to the left. Okay. Okay, so we have our nice little graph here. Okay. Now you guys might remember that we hit this editing box up here so we can change the font size. So I can grab and I can click on the, say, the x-axis, select the option for font and change that to, say, I don't know, 16. And same thing for our vertical font, change that to 16. I also like to change P3, our actual label, we'll make that, say, size 20. And we can click in our legend and get rid of our bin numbers. And in fact, let's just say we can rename old 5s as high confidence hits. And let's rename the bin 87 for the old 4s as low confidence hits. Okay? And then we can select that other button up here to bring it back to normal. Okay, so now we've cleaned up our figure a little bit. Okay? And notice that our figure comes all the way back earlier in time too. Now. So you can look at pre-stimulus differences as well if you're so inclined. Okay? So we can take this and I'm going to save it so that we can plot the figure, we can play with the figures. Okay? So let's say I save that as, let's make that a JPEG. Okay, and I'm going to name that site P3 for hits confidence levels, and that is at P3, and that is in controls. Okay, save. And what I'll do is I'll also open up PowerPoint because we used that to adjust our figures before. So I'll let that open up in the background, and while that's working, let's see if I can create a topography map to go along with that. Okay? So I want to find the difference between old hits that were 4 and 5. Right? We need to plot our difference maps. So I'm pretty sure that that's been 188. Let me just make sure that is correct. So I can select bin 188. I want to do the value to plot is the mean amplitude. So why don't we do between 600 and 900 milliseconds. Okie doke. And we hit the option to display the color bar. And let's just do okay for that. And we can plot. Okay. And this gives us our nice topography figure where we can see that big prominent difference between our conditions that was back here in the left posterior parietal area of the scalp. Okay? So I'm going to save, I'm going to edit that as well. So I can grab that scale. And let's see. Well, we'll fix this in PowerPoint actually. Anyways, point B. Let's just plot that again. Hey, do you guys want to plot that as a 3D hit? Let's make it 3D. We got to create our spline file. It asks us to let's select the option to create a new spline file, and let's just call it spline file. So we'll type that in. I select the option to save the ERP set with that path, so we do OK. And I'll just call it, I'll suffix 3D to our group name. We can save that. Let's see here. Sometimes it works. It looks like it may. You lucky? Yeah, how about that? So here we have our left parietal effect. Looks a little bit nicer this way than flat, doesn't it? Okay. So here, what we're seeing is basically your LPC. Okay? So we're going to want to save this as a JPEG, and we're going to want to label it with, we want to label the time, that is the latency between time points. We also want to label the conditions being contrasted. Okay, so in this case, this is high minus low confidence hits. Okay? And we also want to bring our scale bar a little bit closer over here. Okay? And we want to make sure that our font size is very readable. We also want to label our values, which are basically mu volts. Okay, so I like to use PowerPoint as an editing tool to take care of these little edits. Okay? So first let's save this file, and then we'll move into PowerPoint. Okay? So let's save this as, we'll save it as a JPEG, and let's call this high minus low confidence hits 600 to 900 milliseconds. This is in controls. Okay. So, come to PowerPoint, we start a blank presentation. Now this is what we did last time. Okay, so this should be a review. So I'm not going to go as slow as we went last time. I'm going to move quicker because we've done this before. Okay, go to Insert, Insert Picture, and I'm going to navigate to my data. I'm going to grab first. I'm just going to grab the topography map. Okay. Now the first thing I'm going to do, I'm going to show you guys some tricks. Okay. So a couple things that we need to do Okay, so we're going to have to edit this. And the first thing is we need to get our scale bar, we need to get it moved over here. Okay, this is way too small. Nobody can read this, so we need to rewrite our conditions and our time points. We need to fix this up a little bit. Okay, let's make it pretty. Let's make it readable for our readers. Okay, so the easiest way to do that is to create an exact copy. Okay, and you'll see what I'm going to do real quick in a second. I'm just going to highlight this, copy it, and paste it. And then we're going to slice them and dice them. So, right-click, copy, right-click, paste. Now I've got 2. See? Now, when you have 2, and you double-click on one, you're going to hit this button up here for crop. Okay? Take notes, guys. Expected to do this. Okay? So, what you can do is use these little black bars to edit and crunch this in. So let's take all this white space and let's just crunch it in to just what we need here. Okay? Boom. Just like that. And then just bring it down there. Bring it right there. And then you hit crop again, and it finishes it. So let's move this sucker over to the left. And now we're going to do the same thing for this other big file. Double click on that, hit crop, and this time we're going to block out the whole head and we're just going to grab our scale bar. Okay? In fact, you can make it nice and tight right around it. Okay? So now what you've done is you've made it very manageable. Isn't that nice? Really easy, right? Okay. So, here's what stinks about this. You can't read these, can you? Okay, we need to fix that. Okay, so what we're going to do is we're going to do that same little nifty trick we just did. We're just going to crop it. We're going to cut out these numbers. But before that, you need to make a note. You need to know what they are, because we're going to retype them ourselves. All you need to know is basically what the max and the minimum number is. So know what that is. That looks like it's about 3.2, and this is 1.1. Okay. So I'm going to highlight that again. I'm going to crop it. It's actually 3.7 and 1.1. I'm going to zoom that in. See how I just cut that sucker right out? Just like that. Okay, so now we can even shrink that a little bit. And what we can do is now we want to add a text box. So that's what we have up here. Just hit this little text box. We're just going to type in our little numbers. Okay? Our max value was 3.7. So let's put that on the top. Okay? And we can even, then we can copy that and paste it. So we know it's the same size and style font. We'll put it on the bottom. What did we say it was? 1.1?
Yeah, it was 1.7.
1.7? Okay, let's do 1.7 if that's what you say it was. And so now we have the max and the min of our scale, our topography maps. Okay? Now what else we're going to have to do? We need to put a label on this scale, right? The mu volts. Okay? So let's create a text box again, except this time we need to add in a symbol for the Greek sign of mu. So the way that you do that is you come here to insert, and then you come over here to symbol. Okay. And we want to find the little Greek symbol for mu. Oh, for me it's down here. I've got it right in this box here. So all you do is grab it, highlight it, and press the button for insert. And then close. And then you want a capital V for volts. So that's what we just did here. We put the mu, the Greek symbol for mu. How many of you guys or girls are into sororities? I know at least 2 of you guys, right? 3? So you guys know what mu is, right? You guys know all the Greek letters? Okay. So we're going to use mu here. And put the big V for volts. Now we can have our label for our axis. Okay? And you can put that down on the side here if you want. You can even put it in the green or on the side. Why don't we actually put it there for now? And then what we want to do, give a little spacing, make it look good. Okay? Is we want to group this stuff together because these are all individual little pieces, right? Let's make this one figure so that we can drag it where we need to and stretch it and shrink it. And the way you do that is just highlight all of this, right click and select group. And I'll show you that right now. Okay? So you just highlight all of that. Okay? Right click over one of them. You're going to go group and select group. Okay, so you right clicked over everything you highlighted, just select group, and then group. And that's it. Pretty nifty, right? Oh, I forgot to do something, didn't I?
The latency.
Latency and condition. I'm going to hit Control Z and undo my grouping. Put in those extra elements, and then we'll regroup it. Sound good? Okay, same thing. Now I'm going to insert a text box again. And I'm going to put one text box here and one text box here. Okay? Now let's see here. We are going to do high versus low confidence hits. I'm going to even make that bigger, stretch that all the way across. Okay. Okay. Copy that, and I'll paste it below too, because now it just makes it easier. All I have to do is come in here and change the actual words and say 600 to 900 milliseconds. Now I can select it all, right click, group. Oh, that's pretty nifty looking, isn't it? Are there questions on that process? How do you guys feel about it? Pretty easy? For me, this is a lot of fun. Like I think it's fun to make the data, and especially with cool three-dimensional color heads and all that kind of stuff. Yeah? Okay. So, so we have the important elements that we need here, and that all of your figures have to have, whether it's a 3D map or a 2D flat map. You got to have the conditions labeled of what is being contrasted, because every single one should be a difference wave, subtracting one condition from another. Okay? We want to know the latency, the time that it's reflecting. All right, what window? We also want to know our units, mu volts. We want to know our scale of our values of mu volts, the max and the min. Okay, and of course we want our color scale to represent that. Because anywhere it's red means that there's a big difference between these conditions, and vice versa, relatively lesser. Okay? So that's one section that we have here. Okay? And what we can do now is you can even shrink that a little bit if you need to. Okay. Stretch that out. All right, so we need to add some more stuff though, don't we? We need to do our ERP, right? Okay, so let's just go to Insert. We'll insert that picture that we created. Here's our ERP. Now, what we can do is the same idea. We can double click it. We can go to Crop. Let's bring this in. So in ours, we don't care about this pre-stimulus stuff. So let's keep it at our negative 200 at that point. And let's put that here at, we can put it about there if you want. Okay. We can save some space here and crunch this down, just kind of like that. Crop that in. Isn't that nice how that fits together? Yeah? Okay. Now, one thing that we want to do is we can add a little box. We would like to identify the time point that we are analyzing. So let's grab a little box to do that. Okay? I'm just going to get that box there. Okay. So we grab that box. And we were analyzing basically 600 and 900, which would be about there. So initially we just got this big dark box, and all we're going to do is we're going to flip it around. We're just going to change the colors of the fill and the line. So the fill, we just go Shape Fill and select the option for No Fill. That opens up the box. And let's make it a dashed line instead. So we select, again, I'm up here. I've selected Shape Fill. Now I'm going to select Shape Outline and just change it to dashed lines. And I think it looks nicer. You guys can tell me what you think. We'll go dashes. I like the fourth one down. And for me, that makes things nice. What do you guys think? Does it look a little nicer? Right? These are really cool figures to be proud of, right? I think, at least. For all the hard work you guys are doing? Okay. Now, one thing I like to do, actually, too, I mean, sometimes I'll even erase this, too, or put a white box over it and just type it in even bigger text to make it more clear. But I'll leave that up to you. God bless you. Okay, so let's take a little zoom out on that. Okay. And okay, what we can do with that then is let's morph that together, and we'll do the same thing. We'll group those. Now that's one big file. Whoop, hold on. So I did not group the dash box together. So now we do that again. We'll group that. Okay, so now we've got one nice little thing here. Okay. Now, oh, you know what we forgot to do? We forgot to label our axes again, didn't we? Why don't we add a little text box in there that says milliseconds. You can drag that up over there. Okay. And